Welcome everybody to the very first edition from the Data on Kubernetes community of Nederkube. All right. I am the exclusively non-Dutch person here today. I will be attempting to say a couple things in Dutch, or better yet, to be inviting some of my Dutch translators to help me out. I told Arie this actually before we started. Nobody is allowed to do the typical American thing and say, I'm so excited. If you're going to say I'm so excited, you have to say it in Dutch. And Arie, how do you say that?
What did I send you? I don't know. I was sent it to you.
Something with enthusiast.
Ik ben zo enthousiast. Ik ben zo enthousiast.
I don't know. It doesn't really translate well, right?
No, it doesn't really translate.
It doesn't really. It's not really something Dutch.
True.
But that's kind of what we're here to do today, is to find out about all different things Dutch, the Dutch way of approaching things. I do have to say I am a grand admirer of the Netherlands. I've been there a few times and have family friends that are from there. And I really like the down-to-earth, very practical approach that the Dutch generally have. As an American, I know that sometimes we get too energetic and passionate about some things that may not necessarily require so much energy and passion, which is was very nice. Arie and I actually had the good fortune of working together in the same company a few years ago. And it was great to work with someone who was so practical about problem solving and focusing on the issue and not making things personal. But that being said, Arie, perhaps you can introduce yourself a little bit more formally, explain your role, where you're working, what you're doing with Kubernetes.
Yeah, so I'm Arie, living in Bilbao, just like Bart lives in Baracaldo, but just next door. But we're living in the Basque Country here. That's also where my journey in the cloud started, actually, working for V Global, it was called by then. Now it's called V, I think, just V. That's where we started working with a full cloud environment. Everything was running 100% on the cloud. And that's also where my journey started related to Kubernetes. No? So at the end of my time there, actually, so the last half year before I left, they started implementing and designing solutions on Kubernetes. That was a very big challenge, actually. That was one of the biggest challenges I think I've had. Unfortunately, after that, I haven't been that active around Kubernetes until we started getting into the community. Mm. And now at my current job at Kurago, I'm working as a cloud system engineer. We're providing, or we're setting up a full automated CI/CD environment, and we're planning also to start working with Kubernetes in the short term, within now and a half a year or something like that, to run certain microservices, actually. So not yet data on Kubernetes, but we are there.
We're getting there. And the important thing there, I think, as well too, is a mentality, and that's something we're going to be bringing in. Jeffrey, can you introduce yourself really quickly? You obviously have your own story with Kubernetes. How did you get started?
So that's how did I get started? Good question. So I've been doing storage for as long as I can remember. I rolled into it very strangely, and I've never inspired a career in computing in general. I have a master's degree in electrical engineering, so it's kind of related, but somehow, some way, long story short, I ended up in storage. Worked with distributed storage systems, the more traditional NAS-based systems. And I was kind of wondering, it's like, what I'm going to do next. And I was thinking about, maybe I'll just, start to do, I don't know, more like management type, like related things. And but I got approached by Evan, who is my CEO, and he was then just recently joined MayaData. And they had this idea of applying the container/Kubernetes primitives towards storage to get a more granular approach to how you can configure your storage as you move stateful workloads within Kubernetes. And that's now 2.5 years ago, maybe 3, can't recall exactly. And so I've joined as CTO, and I am there working on building this new storage system that adopts the container approaches and cloud native design from the get-go. And while doing so, we try to obviously write for the future. And we'll talk more about that, what that could potentially mean. But a lot of things come together that made it a very interesting challenge. And yeah, so I'm literally building storage systems that Kubernetes can leverage to store its data. So that's why this community is kind of interesting. Like data on Kubernetes, like sounds like a good match.
You're in the right place. And this is not the first time. And this is the first time we've had you on, and it's also not the first time we have you on with somebody from DataStax. So let me refresh my Dutch to not say the dangerous word that I can't say in English. Ik ben zo enthousiast. Perfect pronunciation. Really perfect. Nailing it. We'll turn it over to our friend from DataStax. Michel, can you introduce yourself and talk about your experience about how you got into Kubernetes?
Yeah, sure. Thanks for having me, by the way. I'm really excited to be here. No, anyway, so first of all, I have to give my apologies because my colleague Arie should have been here also. He unfortunately had to attend some really important other stuff. So
no problem. Yeah,
he cannot be here. I'm here though. I've been in data management, distributed data management for about 15 years. So I think I've seen quite a bit about data management, how you do data governance on top of it, how you make that available in real time, that kind of stuff. And it was about 4 months ago that I got in contact with somebody from DataStax. He was talking about Cassandra, and essentially Cassandra was the only database that I haven't tried yet. So I thought, let's try it out. And I fell in love with it. I just fell in love with it, with the elegant architecture. And so there I am working for DataStax now. The relation with Kubernetes is really cool, I think, because, we also saw Kubernetes rise, out of microservices architectures, and it's just a platform that eases the operational burden for operators. And the cool thing here is that if you look at something like Cassandra, the way that Cassandra has been built, I said I fell in love with elegant architecture. It fits so well with the way that Kubernetes works. Right, the way that you ideally work with resources and distribute work over the pods in a Kubernetes cluster. So that's why I'm here. I'm actually working with some customers now that are moving to Kubernetes. They're moving their data management to Kubernetes, and I have to say it looks really promising. I haven't run into a big issue yet, so
very good. That's good to hear. And that's exactly what we want to hear, because a lot of times there's a sort of resistance to this, or, I need to see more examples. And that's what was interesting. And I want to get your feedback about looking at the Dutch tech landscape. Because on Tuesday, we had our regular meetup with Olaf Molenveld, who's the CTO and co-founder of VAMP. And they focused on software release pipelines, orchestration. And so he was giving me a little bit of background about like sort of major tech hubs in the Netherlands. And in each one is where we can see different things going on in the Kubernetes, and also data, we can say landscape. And so this is where I'm gonna need your help. So obviously from where near Arie is from, because Arie is from, and I'm sure I'm gonna say this perfectly, Vlaardingen, yes?
Vlaardingen, yeah, really good.
Every time I'm getting closer, which is near Rotterdam, which obviously having, the big port presence, there's a physical need for containers, and then also a digital need for containers to be keeping track of all the stuff that's going on there and running applications. Then obviously in Amsterdam, major tech talent hub, you have, lots of enterprise level companies and sexy new companies. And then from what I also understand from a conversation I had with a Dutch company this week that's called Red Cubes, that I heard about through the Google podcast regarding Kubernetes. They are based out of Utrecht, I believe. And I think Arie was mentioning that there's kind of a large like big data community there. So it's kind of a natural fit. Anything to add from any of our Dutch natives about what's going on in the Netherlands?
Well, in terms of locations, personally, I live close by Amsterdam. So a lot of engagements that I have with customers and people that are interested in data management is with organizations in Amsterdam. And I have to say that in Amsterdam, there's another hub, and that's the financial services hub. Right. So Amsterdam is really big in terms of financial services. And that's a whole different story again, I guess. Because when you come across financial services, they're even still running stuff on bare metal, right? So, and
That's
for a
a
reason,
good thing, right?
for a reason, but you can imagine that for those types of organizations, it can be quite a journey to start thinking about, okay, what's this Kubernetes? I hear everybody talking about it, but what can it do for me, right? So.
Yep. That's it. That's a good point. I think also like the sort of resistance that we encounter is that for some people it's legacy systems, or it's just that some people might need to retire so that these kind of changes can be made. Jeffrey, what have you seen?
Yeah, so I spoke to several companies that they catch on the container story and the CI/CD approach, and they all see the benefits. And then Kubernetes is like the missing piece in terms of, okay, but how do I orchestrate all these containers and how do I upgrade them and whatnot? But the reality is that a lot of these companies, and not like the real big ones, but let's say the companies that have IT, but IT is not their core business, let's say, and they struggle sometimes with, okay, so we want to go there. It sounds all good, but how do you actually get there? And mind you, we cannot just turn off the switch on those old systems, right? And so the question is, how do we like create this hybrid model where we can innovate and try to re-implement certain services while we kind of squeeze out the old ones? And I use the term squeeze out. I think there is a official pattern name called the strangler pattern, where you basically wrap existing. So to give you like a very concrete example, I was talking to a company that has acquired several companies across the globe, and they had like one big issue, and they knew it was costing them around 50 million euros a year. By the sheer fact that they could not tell if old personnel was actually assigned. And so they hired external personnel to do certain contractual work that they knew that they needed to do. Because the fine was bigger than the 50 million. And so the question is like, how can we, and this is a very practical example, how can we have 9 different HR databases that we acquired as we grew into one and make that all work for us, right? So they have all the data, they just can't get it out. And so how do you go from there? And obviously, I think one of the interesting things about the Dutch is that they talk a lot before they actually start doing. So everything needs to be dotted and crossed before they start working on things. And so it's sometimes a little bit, they get stuck in this like nobody has the real oversight and things can go, pretty bad. But
we have a word for that, right? It's called the polder model.
Right, exactly. It's like keep talking until everybody's okay, never mind. But this is like a very simple example, and we work hard with them trying to find like, don't try to boil the ocean. Try to find something tangible where you have short cycles where you can actually demonstrate that the effort and the work that you did now yields a result. All databases are wrapped into an API. And that's like the start, because then you have the abstraction. And once you have the abstraction, what is underneath is not all that important anymore. So these are very, very simple examples. Similarly, it's like I have an existing database. I want to connect that to Kubernetes. How do I do that? Do I first need to put all my data inside Kubernetes before I can use my database within Kubernetes? Obviously, the answer to that is no, but these are very, simple, or not simple, but questions that live by these people. Maybe not for the developer necessarily, because developers never see problems, just opportunities. But the people responsible for a whole department might, get a little bit nervous, to sort of speak. If it was like, yeah, we're going to move the database. It's like, really? Are you sure? So yeah, that's a little bit of the things that I've seen. Yeah.
Good. Now, first to go to Michel and then also go to Arie, is that, Michel, you're working directly with clients, and something that we talk about a lot is, okay, before, we can get into lots of technical details about operators, about this, that, and the other. But one of the fundamental things here, we have an expression in the US that if it doesn't make dollars, it doesn't make sense. And I also want Arie to get on this afterwards. But if you're approaching this, from a business case of saying, look, this is a good business decision to be making to move your data to Kubernetes, how do those conversations work? How do you provide context to say, look, this is a good idea? Is it for everybody? How do you do it?
Yeah. So that's really a good question. Because in the end, in a commercial organization, I guess in most organizations, it's also about total cost of ownership, right? And so if you look at Kubernetes, I think that there is a real advantage there in terms of operations. The operational burden becomes less. It becomes easier to spin up new environments, new pods. And as Jeffrey also said, it allows you to start playing around, understand what works, fail fast, and move on, right? It's much more difficult to do that on premises. And in particular, one of the things that really resonates with customers that I talk to is the multi-cloud aspect. Because sure, you have Kubernetes and you can run Kubernetes on premises. All the big cloud providers, they also have, of course, Kubernetes implementations. But the cool thing about Kubernetes is that you can start spanning clusters over multiple clouds. And this is just mind-blowingly cool for me and for most customers. Because, personally, I've seen cloud providers fail also. Right? Not often. It's rock solid, but it happens, right? So last week I had Google Cloud go down for me for a small part. If you have the possibility to solve that issue by spanning your services over multiple clouds, which is something that you can start doing with Kubernetes. And of course, you need the right technology for it. Then that is a big advantage for customers. So that's the first one. Second one is, if you do that, you also have the possibility to decide where you are going to store the data, right? So you can decide, hey, I have my personally identifiable information in terms of GDPR. Oh, wait, I'm going to store that on premises, right? Because that's really, really important for me. Likewise, with PCI data, for instance, payment information. Oh, I'm going to really trust GCP on that. So I'm going to store that on GCP. Analytical data. I want to make use of the cool analytical features of Azure. All right, so I'm going to move that analytical data to Azure, while still being in the same cluster, while still all being highly available and readily available for operational use. So I think those are some really, really big, huge business benefits. Or there are things, opportunities that lead to business benefits for customers. And that's something that really resonates well.
Is that, like you said, that agility and freedom and comfort? Arie, what are you going to say?
No, I was going to jump in on it because you mentioned my name before. No, this brings us to the discussion that we, at the end, we always end up a bit in the same direction now, where we get to costs versus the expertise that you need also to implement it, the security, is the mindset there to this is the typical part where we go now always, like, are the companies really ready for it? Do they know what it is? Like, are they did they self-educate themselves? If you start talking, at least that's what I've seen from experiences. I don't want to be against the Kubernetes solution on multi-cloud and
no, like we're going back to the Dutch concept of polder model. I think that's
yes,
that's it.
Yes, that's great, but
that comes out. But what you see a lot on the market is that when you start mentioning multi-cloud, that you need to you need to have multiple machines to cover your load, and just in case something drops out or something, then especially the Dutch maybe see all the dollars disappearing or the euros disappearing there, and flowing away. So yeah, no, that's what I've seen, at least, right? Talking to different people. And I've been talking or trying to engage with bigger companies also to set up these Nederkube editions that we're trying to organize. And I've been talking to some old schoolmates that work in Shell, for example. I got one working also in KPMG. And then what do they say? Yeah, we're just running still on a Docker cluster, for example, and we're comfortable with that, and it's running on web apps or in Azure then, for example, and we're okay with that at the moment because they're afraid that it's running out of hand once they get to something else. No, I don't know what it is exactly, but it's the mindset, the knowledge of what there is, because the solutions of a DataStax and of MayaData. Yeah, they are good. They are super good to go. They're a perfect fit for this.
Arie, it also depends. If I may jump in, it also depends a bit on the use case, right? And if you're, for instance, a regulated vertical. So what I see, for instance, in financial services is they're interested in moving to the cloud, but from a regulatory perspective, they need to have an exit strategy. Yeah, so that has nothing to do with functionality or business value. It has to do with the fact that they just have to have an exit strategy. And in that sense, having a solution running with Kubernetes that allows you to just switch within, I don't know how many seconds from one cloud to the other cloud. Well, that's having an exit strategy. So it's also those kind of non-functional requirements that I think are really important.
Yeah, and everything is available for that. I mean, the cost management tools that we've tried or that we've seen, they're all capable of grabbing those costs that go along with that, and to manage it, to have visibility, to get your reports of both clouds, everything based on tags and groups, projects. You can see that. I mean, there's no. There's always a negative side, but there's not really a negative point there. No.
Yeah.
It's very interesting.
Good. And Jeffrey, in your case as a CTO, how do you detect in the case of the customer if they have the right situation, the right use case to apply the technologies of MayaData, let's say, related to storage?
Well, so it's usually, or I should say, fortunately for me at least, I think the most interesting cases are where they build something new, which opens opportunities. And because you're building something new, you obviously don't have this legacy to pull in, and that makes trying out new things a lot easier to start out with. And then they rather quickly start to think about, okay, mobility and exit strategies, for example. So those are absolutely valid points. And then they start to think about, what is it in fact that I'm actually trying to achieve, and where are the scalability aspects that I need to have in order to make the architecture as I lay it out in such a way that it allows me to scale regardless of the actual cloud infrastructure that I'm using. Because the snake in the grass, let's say, is the cloud provider, right? Because if you run on Amazon and they have fantastic services, but if you architect your application towards it running in Amazon, you'll find out having a hard time to move it on-prem if you, for whatever reason, need to do that. And I've been involved in several cases where that was happening, where they were fine with Amazon, but if for whatever reason they needed to get out of there, they kind of needed the exact same environment on-prem, which is obviously not trivial to do. So the composability and the extra level of abstraction that Kubernetes provides, that mitigates that problem to a certain extent. And the reason when they are interested in using us is like, okay, so how can we achieve the same thing for data? Because spinning up containers, you can do that all day long. That's great. Through Kubernetes, you have this unified control plane. It doesn't really matter if you're kubectling against an Azure cloud or a Google cloud, let's say. But for data, things are a little bit more complicated. And when I say data, I actually mean the physical blocks that are laid out on the physical media. So I'm not necessarily talking about database data per se. But how do you abstract that, right? So I have my database now locally on this Kubernetes node through a stateful set, let's say, and now for some reason or the other, I want another machine to connect to that. How can I do that? So these are the type of discussions that we're having. And the other thing that obviously, fuels these discussions a little bit are things around DPUs, for example, CSI standardization. What does it mean for me? How can I ensure that I don't paint myself in a particular corner? How do I make sure that if I buy a very large instance in the cloud, that I can get the bang for my buck, software architecturally wise, because the storage systems are getting faster and faster, and storage for the most part now is faster than CPU, and that has never been the case for a long time, right? So a lot of these conversations fuel a lot of the questions they have, and so a lot of these things lead to us getting involved one way or the other. Yeah.
All right.
You would say also that the like external storage or external storage, I mean storage that's not hosted in the same cloud provider would be the future in that sense, no? It's
the ability to make your data as agile as the applications that they serve, because usually data sits on a box and it sits there, and you get this phenomenon as data gravity, that everything starts to evolve around the data and it has to be close to the data because latency and whatnot. And if the storage blows away, all your microservices blow with it. So it's like doesn't really help. So as you decompose your services into microservices, so does the data. And then things become more manageable, because now you're not talking about copying, 2 petabytes of data from A to B, but small 200 gig sets, which is still a reasonable amount, obviously, but it's more manageable than these long data migration paths that you saw in the past with the forklift upgrades and things like that. And people sometimes also incorrectly, in my mind, assume that, well, I'm running in Azure or Amazon and I have EBS or whatever. It's fine, but still somebody needs to manage these volumes, right? Even though that you don't own the box that serves the volume, it still needs to be managed, right? Who has access to these volumes? Who creates them? Who can attach them to what? So you still have these storage management aspects that you need to consider, even more so if you go through different clouds. And then lastly, you see more higher performance workloads popping up in the cloud as well. And you see situations where people use physical storage in the cloud, but nonetheless, it's still like a dedicated machine. And they also want to transparently consume it as if it were an EBS volume, right? So it's like a physical server in the cloud, but it should walk and talk and quack like an EBS volume, let's say. So yeah, the abstraction, ideally zero cost, is what makes it something that gets us involved.
Good. I've got to hand it over to Arie really quickly, because I actually have a call with someone from MayaData and somebody from DataStax. But I'll jump back in a second. Arie, I want you to get them deeply into the debate between stateful and stateless. And I want to remind that Jeffry said there is no such thing as stateless in our previous meetup that we had. So Arie, I'm going to turn it over to you right now. I'll be back in a bit. Okay,
great. See you.
Bye-bye.
No, I just have one question related to what you just said, Jeffrey. So when we talk about having the storage outside of the data center where you're running your Kubernetes cluster, or in case of even in multi-cloud, maybe you run it on a third party. You're contracting a third party service for the data, with high high-speed data options. So what is then the biggest thing that clients or people walk against? Like, what is their biggest problem there? Do they not are they not concerned about the costs of networking or about these kind of things, or the latency between these different clouds and services?
Right. Yeah. So software can never mitigate physical latency of course. So, it's like there is no magic bullet to eradicate latency between different data centers and whatnot. But depending on the type of customers, a lot of the customers have this backbone connection to a this big fat pipe, let's say, and they have their failover service. So usually they had 2 data centers and they would replicate between them, and the more expensive environments had a cluster across the 2 data centers even, so they could have transparent failovers and whatnot. And what you see is that this failover data center is starting to move towards the cloud, because you can save a lot of money there, and then as they are in there, they start to consume the cloud because it's so easy. It's like, well, I could just click this button and boom, I have a VM, opposed to asking for a resource in the VM, going through the paperwork, and 2 weeks later you might have a VM, right? So
Yeah.
it's like this instant on-off and instant gratification, really, when it comes to IT, and then all of a sudden you have some useful data in your cloud, and now the question is, okay, so but how do I get it back, right? And these are things that you can actually achieve relatively simple if the data is actually or if the connection is fast enough. But it doesn't have to be like instant. Sometimes you could have an asynchronous copy happening in the background as well. But what you can, for example, do is you can put this well, I don't want to get into too many specifics, but we call this a nexus. You can insert it in the data path, and then all I/O is served as normal, but as it gets served, we can route I/O somewhere else. And if you wait long enough, let's say you have a complete new copy of your existing data while the data was online. And these techniques are not new, by the way. These techniques have been on the market for like forever, but usually they have been in like more hardware type like solutions. And obviously when I say hardware, it's just, a Dell server with a sticker on it, but you get the point. We're more like appliances. And now, because CPUs have gotten so powerful, because network bandwidth has gotten so high, you can do this in software. And the nice thing is then through the orchestration layer, you can define like exactly for what piece of the puzzle you want to have that happen. Whereas the more traditional aspect is like you can replicate the whole volume or nothing at all, right? So, well, I just want to create a small part of a volume. And in particular, when you're talking about virtual machine type like constructs where you had a data store and all the VMs are on the data store, and you could either replicate the whole volume that is in the data store or individual pieces through third-party software again. But it's never been this granular, and this is something that makes that more feasible, more so because the individual data sets are somewhat smaller, right? So you don't see a single container running a petabyte of data, for example.
Yeah.
So yeah, so that's one of the yeah, I hope that answers your question somewhat.
Yeah.
Yeah. And yeah, sorry, go ahead.
No, I was wondering, like, Michel works with with DataStax, with Cassandra. I mean, they're running also their services, of course, on Kubernetes. That's what it's at least what you're going for. I've been reading through the blog lately, also pretty much seeing what you guys are trying to serve. So how do you stand in that point also of no, we can actually make this get going to a bit to the part what Bart said, no, the stateless versus stateful also at the moment, but like
yeah. So to come back to the stateful and stateless, so there was this previous don't know exactly the date, but I said, well, there is no such thing as stateless when you come to think of it, because a computer, by virtue of it being a von Neumann cycle, it's always stateful. The question is like, do you care about the state? Is it ephemeral or not? And is it, so the worst thing that can happen to me when I'm shopping at bol.com, to stay in the Dutch zone, it's like, if that service crashes while I'm shopping, the worst thing that can happen to me is that I have to fill my basket again, right? So the implication of losing the data is not all that big. Now, obviously, if Bol would lose its inventory database, like that's a freaking disaster, right? Mm-hmm. So it's like, where on the spectrum are you, and where does it matter if you lose the data? What is the implication? But computers, by definition, always have state. So databases like Cassandra have the ability to have a fine-grained control over the stuff that you store within the database, how that data should be available. So how that relates to what we're doing is that we don't have to do any sophisticated replication or what have you in order for us to be useful to you, because as you have physical machines, let's say on an on-prem Kubernetes cluster, like maybe you're running OpenShift or something like that, it's kind of useful to have a system that allows you to leverage the local devices in any way you want, such that you can give them to a system like Cassandra, because at the end of the day, Cassandra needs to have storage devices, if you will, that allows it to store the data that it tries to store. So it's like, yeah, you just have a disk. You just gave us a disk. Yeah, we just gave you a disk. In that particular case, we just gave you a disk. Yeah. Mm-hmm. If that makes sense.
Yeah. Michel, you want to comment on that? Especially about your part now, your role and your position with Cassandra and.
As I said, I'm really into the data management part, right? And data management usually, as Jeffrey also says, is something that has to be quite stateful. That's something that you expect. However, I think that the whole discussion about stateless and stateful is really interesting, because if you take a good look at the possibilities that Kubernetes gives you, it's also something that we are actually utilizing. So Jeffrey did the best explanation about Cassandra that could be done. I probably wouldn't be able to match that, but he's right. Some of the innovations that we've been working on now is a new project called Stargate. I don't know if Jeffrey or Arie, you heard about that. Now, Stargate essentially is a solution that allows you to distribute the load between compute and data management, to distribute that off of each other, right? So the Cassandra nodes in the cluster that are responsible for storing the data don't really have to take up on the computation workload anymore. That is something that is now handled by something else, which is done by Stargate. So Stargate allows you to attach to the stateful containers that run for Cassandra with the persistent volumes, and Stargate then allows you to run the computation workload on the nodes that are available out of Stargate. So I think that that's a nice example also about how can you leverage the capabilities of the of in this case Kubernetes, so that it works for you, allowing you to create better performance on your stateful containers running Cassandra with persistent volumes, and on the other hand, the containers that are running the computation workloads, which obviously can be stateless.
Yeah,
and so I really like that separation of concern that is possible because of this.
Yeah, and that's actually a good segue into something that just popped in my head, and because what you see is that the requirements that you have for running compute are vastly different than for running storage. You
Yeah.
need a lot less CPU to saturate your storage backend than you would need to, I don't know, do some machine learning exercise, right? So you see a lot of this, they call it, you know, let's say storage segregation, where you have a set of machines, either physical or virtual, doesn't really matter, that have specific roles to do the data storing part. And then you have the compute layers that connect to those storage layers, if you will, that do the computational part. And you scale them very differently, and they have a very different price tag along with it, obviously, when you buy them. So being able to split up these different roles, if you will, in terms of what the system needs to do is something that the hyperscalers do a lot. Actually, I was at a presentation from eBay, and they basically talked about how do we, you know, scale and how do we design our data center, which was very interesting. And they have this clear separation of compute, storage, and networking. They're all hardware in the sense of servers, but they're just all servers.
How do
you know, and I think that sorry,
Michel, yeah, you can finish it in a second. Just one question in the middle. How do I see this separation, like from a management perspective, like me being a system engineer or administrator, managing that, no, right? Like, do you give me different parts with different resources there, or how is this separation done?
Yeah, exactly. It's a matter of defining the resources for the different types of pods. You know, essentially, when I was talking about Stargate, it's also a Cassandra node, but then it's a specialized node that doesn't do any data management and data storage on it, right? So with that separation, it also allows you to define different types of resources for those different use cases. So that's quite easy to do. Actually, it brings another big advantage, and that is something that more and more organizations are interested also, and that is serverless, right? So if you're able to run your computational or evaluation, I should better say, evaluation workloads separate from your data management workloads, you know, it also allows you to scale them separately, as Jeffrey also mentioned. Having that allows you to suddenly step into the world of serverless, yeah, and that is something that DataStax themselves is now using. So we have the Astra offering, which essentially is Cassandra as a service, but now we're going into beta with the serverless offering, doing exactly this, you know, scaling these two types of workloads separately from each other in such a way that you only have to pay for the actual amount of usage that you use those two types of workloads. You know, so I think that I'm afraid to mention the word again, but coming back to total cost of ownership, I think that's a big advantage in that area.
We've got one question because we're still within the area. Now we're there with the stateless and stateful. There's not been really a big debate there because I think you're both on the same. No, you're thinking this in the same way in that sense. But from if I'm pronouncing it well, Yves Weiser asks, did CSI kill the stateless versus stateful debate? So CSI is being orchestrator, no, an orchestrator not. It's the service that can manage storage, right?
Yeah. So CSI is the standardization, if you will, of a set of RPC or gRPC to be exact, methods that if a storage system implements these methods, it can be used within Kubernetes. So it's like an abstraction. It comes in with three major components: controller, an agent, and one I can't come up with right now, a register, I think. And the controller basically is responsible for receiving the requests to create a volume, it does whatever it needs to do, which is very specific for storage, per storage vendor. And then the agent that runs on the node, like the kubelet, that does the actual mounting and mount propagating and whatnot. And this allows any storage vendor more or less to connect to Kubernetes, and they just know that it should and would work. But the actual question is did it kill the debate? And this is oddly enough, although I'm in storage since like forever, I think the less data you keep, the better it is for your own health, right? Because if you don't have the data, you don't have to worry about, for example, the data breaches, right? If you don't have the data, you don't have to worry about backing it up. So the less data you have, the better it is. So the less state that you can keep, the better it is for yourself. Obviously, you should keep enough such that you can keep the data that is valuable. But the notion that CSI makes it, let's say, irrelevant if it's stateful or stateless, I don't necessarily think that that's the case, because there is this implicit ordering that happens, for example, when scheduling. So what that means is that the volume, the CSI volume, needs to be there before the workload can start. That's one of the things to consider. The other thing to consider is like, are all the nodes on the same network as the storage system, right? And typically, in a traditional sense, that usually is not the case. They have two different networks, the local area network and the storage area network, and they were separated for good reasons. So it is not like the solution to everything and anything, but it does make starting off easier. And the other thing to consider is that if you have all those Kubernetes nodes connected through CSI to your storage system, whatever storage system it is, if it is a proprietary storage system, it's even more dangerous, I should say, or could say, is that if the storage system fails whenever it's distributed or just a single box or whatever, all the workloads in Kubernetes die with it, right? So it's like this avalanche effect.
Yeah.
So one should tread carefully to consider stateless and stateful like all the time, regardless of CSI or not. I think,
Yeah, that's a good point. That's a good point. You should always take it into account. You don't know. You don't really need to be stateful when it's not necessary in that sense. Eves, sorry if I'm pronouncing it wrong. I think it's Eves. Eves says good point. He or she made another comment. After serverless, you get storageless, and then is the comment. Serverless is what Michel already mentioned before. So storageless, would that be a possibility then? If there's a wink there, of course, involved.
Yeah, well, so it depends on. I mean, there are certainly innovations happening, if you will, in storage land. So to give you an example, certain companies that do some sequencing on whatever form of data, could be an image, could be whatever. Let's say that they want to run something in the, or let's say a big picture, like a big photograph, and you want to do some image analysis on it. More often than not, when these type of systems are deployed within Kubernetes, what you see happening is through a form of an init container, the object gets downloaded, then the object is downloaded on that node where the workload was scheduled. Then the actual application that does the algorithm gets started, right? And then it does its computation, it puts the results somewhere, and then the container is destroyed and the data is destroyed again, and you have your results. So that's what you typically see. And the init container is the actual thing that copies the data from the cloud to that machine. And it's like, well, that's a little bit upside down, is it not? It's like, why would you not do it the other way around, where you start up the container where that object already is, right? And so that ties into things like computational storage a bit, where you see a lot of that happening, where you put computational power within the storage systems, where you could say that your storage system almost becomes a computer with a hard disk. And it's like, wait a minute, what do you mean computer with a hard disk? So it plays a little bit with your head, but you get the point, right? The storage systems themselves become far more sophisticated, and they have embedded CPUs that allow you to do certain things. And these things start out small with error correction and checksum, access things and stuff alike, but also because the gaming industry recently, I don't think you can buy them yet, or at least not that I know of. Let's take the PlayStation 5, for example. One of the things that they said that was cool about it is that they had the ability to directly move the data into the GPU. It's like, yeah, okay, so what does that mean, right? Because what today on all of our machines, what happens is that the CPU and the hard drive and the application, they all communicate in tandem to get data from the device into memory, and then it's like this handoff constantly where the kernel is doing all the waitering, if you will, and with these smart NICs and data processing units, it is basically, it allows the storage to directly talk to, in this case, the GPU, and the benefit of that is that the CPU doesn't get involved, first thing. And secondly, the CPU would just get in the way anyway, because these GPUs are so fast, the PCIe devices are so fast. So you get this peer-to-peer data transfer. And so you see a lot of stuff happening in that space as well. It's NVIDIA, or Mellanox, who was acquired by NVIDIA, had technology that does exactly that. And so it's like, yeah, you get into this point where you have this, you could envision yourself a Kubernetes cluster where your Kubernetes nodes are not regular machines anymore, but could be either a DPU or a smart NIC or a smart hard disk, right? So, and it just abstracts it all away. And for the operator, it doesn't really matter. He just types YAML, if you will.
Yeah. At the end, all the hardware is evolving also in that sense, and getting different roles in that sense. We have 7 minutes left on the clock. I was wondering, Michel, I don't know if that gives you a little bit of time so that we still have 2 minutes or 3 minutes at the end for the last summary to show something. Did you prepare anything, Michel?
So we were talking about a bit of a demo, but I think it's a bit difficult to do that in such a short time. So maybe we should schedule something some other time for that.
Okay, no problem.
So I'd be happy to do that. I think it's really cool to see, how all these pods come up, and it will be just great watching them all come alive together, and
or die together, fingers crossed.
Well,
like
maybe die a few times before they come up, all that kind of stuff. So I'd be happy to do that some other time.
Okay. So as a closing point, not the last point, but one of the closing points, I've sent it to you guys yesterday. Any war story to tell? Michel, you mentioned that you do not really have a war story yet for the group to share with us, but any war story about something that broke, a cluster that totally went, well, I don't want to swear here, or
actually something that really works. I think that's really cool.
That's also good. Yeah.
So I worked with one of the largest airports in Europe, and they're actually running now their operational processes on top of Kubernetes. So in my mind, that is just so cool. You get into the car, you're in the taxi, you get your app to understand, hey, which gate do I need to go to? Where's the security check-in? You enter the airport, you have all these screens where the information about landing and the flights are. Imagine that not working, right? Imagine a million people coming to the airport on a day, not knowing where they have to go. imagine the planes needing to taxi to the gates, not knowing where they have to go. If that operational process doesn't work, you better close down the whole airport, because it will become a big mess.
Yeah,
right?
yeah, of course, yeah.
So I think it's a great example and a mind-blowing example to see that even those types of operational processors, people trust them to run it on Kubernetes. And to me that says that Kubernetes is mature and ready to run critical workloads.
Nice. Yeah, totally agree. That's a very good, it's a very good story. It shows the maturity also of these technologies. If companies, it's companies, or how do you want to call it? And a whole airport. Now that's multiple companies. But if a big place like this is using that, Jeffrey, any war stories from your side in 2 minutes?
Well, so it was not with Kubernetes. It was with Docker Swarm. And a combination of Compose. But the hidden snake in the grass that Kubernetes can't rescue you from is this phenomenon called firmware. And it is deeply evil. It is dark. Nobody knows what it does. You can't touch it. You can't change it. You're completely held hostage by it. And the one of the interesting examples there was I was waking up and I was working for a different company, and my boss back then, his name was Bill, God bless his soul, he texted me with a little text, help, because something wasn't going well. And it turned out that we had this big Docker Swarm thingy, and I don't know exactly what those containers were doing, and quite frankly, I didn't care, but they all would crash. And you guess it was our fault, or so it seemed. It turned out that there was a JBot, which is a big box where you put disks in, and they have this backplane which is operated by a small computer, which is running firmware, and that thing decided to reboot, and it did so actually with a certain pattern of 3.5 hours, and so the system would come up. 3.5 hours later, the small chip, it's like this, not even the size of a credit card, right? Very, very small, rebooted, and the whole infrastructure on top of it, $2.5 million, was just pointless. So firmware is should be anybody's enemy right now. So yeah.
Yeah, but the comment we have from Yves is firmwares and compatibility matrix.
Oh yeah, those are the other ones. Yeah.
Very good one. Okay. Nice story. Expensive story. That would have been, I guess, a very expensive story if something so big goes down. Yeah.
Yeah, and it's usually nobody knows how these firmwares work.
No.
So it's like, yeah, we'll send a new one and hope that it's better, and obviously it wasn't. So yeah.
Yeah. No, to close up the conversation, as some of you know, we always try to do something special during these meetups. During the Tuesday meetup, we have a sketch artist, and that's what we've used also here, which is sketching what we've talked about on the background. I guess there will be some Dutch things involved and everything. So I don't know, Gorka, can you show us Angel's screen, please? There it is. If you can see, look at Bart's screen. So there we are.
Wow.
Typical Dutch, with the orange and everything. So that's like our thank you to the speakers involved. Amazing. For their time. So really cool. Now, in the name of the DoK community, nice. we want to thank you for participating. Of course, I guess that we will be in touch for future meetups. You're both also in the DoK community Slack group. So anybody who is not a member yet of our Slack group, just join our Slack group, and you can ask any question you want to Jeffrey and Michel.
Yeah, I know. I would like to add to that, if I may. So, like, if there is a particular topic that we should zoom into and handle it a little bit more in depth, let us know, right? And then we can have it a little bit more focused, because we're a little bit overall the map, of course, right now, which is
this is as a first kickoff for the Dutch DoK meetups, for the Data on Kubernetes meetups. It has been a nice general overview. The idea is to in future meetups to maybe go into more detailed topics and touch base there. I want to thank you both for your time, and definitely we'll stay in touch. So, and thanks of course for all the attendees. Next month we will try to be there again, probably also on a Thursday around 4 o'clock. So have a good afternoon. Thanks.
Thank you.
Thanks, guys. Thanks for having us.
Okay.
Bye-bye.
Thanks. Bye-bye.